So let's discuss applications that involve right triangles as well as angles of elevation and angles of depression. So the most important thing to remember when dealing with an angle of elevation or an angle of depression is that it has to come off of a horizontal line. So if this is my horizontal line, and let's say I have an angle of depression, maybe that is, 37 degrees, well, then I would draw that angle off the horizontal line. So this would be my angle of elevation. Likewise, if the 37 degrees was an angle of depression, again, it would come off of a horizontal line and it would come down this way. So this would be the angle of depression. So in some of the applications that you'll see, the picture's already drawn for you, but I think it's good to keep those things in mind. So for example, we have a ramp 15 feet long, rises to a platform that is 12 feet off the ground. Find x, the angle of elevation of the ramp. Round your answer to the nearest tenth of a degree. Okay, so we're looking for this angle, which is an angle of elevation, again, coming off of the ground. We have a right triangle, and we know two other sides of that right triangle, right? We know the hypotenuse and the height over here. So because I know the opposite and the hypotenuse, I'm going to set up a sine ratio. So I can say sine of x degrees is equal to, opposite is 12 over 15. And so remember, to find that angle, x is going to be equal to, I'll use the sine inverse button on my calculator. So I'll take sine inverse of 12 over 15. So I have the Alex calculator over here. Make sure you're in degrees. We're going to use the sine inverse button. And again, that's 12 over 15. We get 53-ish. So let's double check. We're supposed to round to the nearest tenth. So that would be 53.1 degrees for my angle of elevation. So now let's look at something that's just a little bit more involved, but along the same lines. So you have a plane descending at an angle of 1 degree from the horizontal. So we can see that's an angle of depression. The plane's current altitude is 7.5 kilometers, so that's indicated right here. And again, this is not drawn to scale. Okay, so we are to find the plane's new altitude, which we're calling h, after 0.25 hours. So we're told the plane is about right here after 0.25 hours. And we're told the constant speed of 500 kilometers an hour along the direction of its flight. We're told to carry our intermediate computations to at least 4 decimal places, and then we're going to round to the nearest tenth. Okay, so let's think about this. Let's think about what we know. So we have this right triangle here. So I know if this is 1 degree and this is 90 degrees, I can subtract 91 from 180 to get the angle measure of this angle. So this would be 89 degrees. Okay, so let's think about what else I know. So we've got the flight, right? It's going along this line. So we can find the distance there. We can find the length of that line because we know distance is equal to rate times time. And we have that rate of 500 kilometers per hour. And we have the time of 0.25 hours. So we multiply that together. Let's see, so we have 500 times, Okay, 500 times 0.25. Definitely didn't do that right. So right, we're taking 1/4 of 500, so that should give us what am I doing? Yeah, it looks better. I think I was hitting divide. So 500 times 0.25 should give us 125. So that gives me this length right here. So that would be 125 kilometers. So now I have, let's see what else we know. So we're looking for this red line here, this H. So the distance from here to the ground. And I do know that all the way to the top where the plane is, that is 7.4. So I can find this side length by setting up a trig ratio. Since I know 1, this would be opposite, and that 125 would be the hypotenuse. So I can set up a sine ratio. So I can say sine of 1 degree is equal to x, which is what I'm looking for, over 125. And then when I multiply 125 to sine of 1 degree, let's see what we get. So let's see, we'll have sine of 1 degree, and then that gets multiplied by 125. So we get, let's take that out, it's at least 4 places. So that would give me 1, 2, 3, 4. So that gives me an x value of 2.1816, we'll round. Okay, so now I can subtract 2.1816 from 7.4, right? If I know this whole distance right here is 7.4, if we subtract from that 2.1816, then I will know this length right here. So let's do that. So 7.4. And from there, we'll subtract 2.1816. And that gives me a length or a distance there for our h of 5 point, let's see, it says to round to the nearest tenth. So we'll say 5.2 kilometers.